The desert doesn't forgive anything, not the heat, not the silence, not the things a man sees when he has nothing left to do but watch and think and wait. In the summer of 1942, a 40-acre internment camp sat 12 miles outside of Marana, Arizona. Canvas tents, chain-link fences topped with coiled wire, guard towers that caught the last of the evening light and threw long shadows across the dirt. The men inside were not soldiers, they were not criminals. Most of them were accountants, teachers, shopkeepers, men who had built quiet lives in a country that had, in a single Sunday morning in December, decided they could no longer be trusted. One of them was Victor Arndt. He was 38 years old. He had been born in Vienna in 1904. He had arrived in America in 1938 with a leather suitcase, a head full of equations, and a certainty that the geometry of spinning blades could solve problems that fixed wings never could. He had spent 4 years building that belief into something real: consulting work, patent filings, a desk at a small aeronautical firm in Ohio where his colleagues called him Victor and pretended not to notice his accent. 3 days after Pearl Harbor, 2 FBI agents knocked on his apartment door at 6 in the morning. They were polite. They showed him a piece of paper. They told him his Austrian passport made him a potential security risk under Presidential Proclamation 2526. They gave him 15 minutes to pack a bag. Victor did not argue. He had grown up in Vienna in the years when argument was dangerous. He knew what it meant when men in uniforms knocked on doors with pieces of paper. He packed clean shirts, a set of drafting pencils, and 3 engineering notebooks. He left the apartment unlocked. He never went back. The camp at Marana held about 200 men. Most of them spent their days in a stupor of boredom and disbelief, playing cards, writing letters that may or may not have reached their families, sitting in the thin strip of shade along the eastern fence in the late afternoon, and not talking about what might happen next. Victor did not play cards. From the first morning he borrowed paper from wherever he could find it, the backs of envelopes, margins of old newspapers, and when those ran out, toilet paper. Rough, tan, barely functional as a writing surface. He pressed carefully, kept the lines thin, made each sheet count. He was working through a problem he had been circling for 3 years. The problem was this: rotary wing aircraft had been climbing toward viability for 2 decades, and the fundamental obstacle was not power or materials or aerodynamics. It was control, specifically the ability to manage cyclic pitch, to tilt the rotor disc in any direction and translate that tilt into precise, predictable movement. Everyone who had tried to solve this problem had built a machine specifically for the purpose. Complicated, expensive, fragile. Victor believed there was a simpler way. He believed you could take almost any platform, a frame, a chassis, something that already existed, and mount a free-spinning rotor above it. The rotor would not need an engine. Moving air would do the work. The platform would descend slowly, steerable, recoverable. He had proven the math. He had not yet proven the machine. He worked on the toilet paper and waited. The fence that ran along the northern perimeter of the camp stood about 60 yards from the eastern boundary of Marana Army Airfield. On clear days, Victor could watch aircraft take off and land through the links of the chain wire, trainers mostly, the occasional transport. Sometimes, in the late morning when the air was still cool enough to allow useful test work, he would see experimental equipment being towed along the runway's edge, strange shapes under canvas tarps, things the Army was not ready to show the world yet. One morning in April, he saw the Waco. The CG-4A glider was the Army's current answer to a problem Victor understood well. How do you deliver heavy equipment, vehicles, artillery, men, into territory where parachutes aren't enough and runways don't exist? The Waco was a reasonable answer: fabric over a steel tube frame, room inside for a jeep or a howitzer or 13 fully equipped soldiers, towed to altitude by a C-47, released, glided to Earth. The machine coming down the runway that morning was moving too fast. The nose was slightly high, the approach angle shallow, the kind of configuration that worked on paper and killed people on grass. Victor watched. The Waco touched down hard on its left wheel, bounced, skipped, and then the nose came down and caught a rut in the ground, and the whole aircraft corkscrewed 30 feet into the dirt at 40 miles an hour. The sound reached him a second later, not the crash itself, the aftermath, metal tearing, metal, something that might have been a human voice or might not have been. 3 men were inside. The emergency vehicles reached the wreckage in 4 minutes. Victor stood at the fence and watched them work for a long time. He did not look away. That evening he asked a guard for writing paper. Good paper, he said, just a few sheets. The guard, 20 years old, from Indiana, who had started bringing Victor an extra bread roll with dinner 3 weeks earlier, without explanation, came back with 5 sheets of clean bond paper and a sharpened pencil. Victor wrote for most of the night. He did not write to a senator or a lawyer. He did not write a petition. He wrote a technical proposal addressed directly to the office of the Chief of the Army Air Forces in Washington, 12 pages, diagrams on 4 of them. He described the problem, the fragility and inefficiency of large conventional gliders for vehicle delivery, and then he described his solution: a free-spinning rotor mounted directly to an existing military jeep. No fuselage, no wings, no dedicated airframe to build, transport, and abandon. The jeep itself would be the aircraft. Upon landing, the crew would detach the rotor assembly in under 10 minutes. The vehicle would drive away. He calculated the rotor diameter required. He estimated the tow speed needed for auto-rotation to sustain lift. He walked through the descent angle, the landing speed, the load tolerance of a standard Willys MB chassis. At the end, he wrote one sentence that was not technical. I am aware that my current status may cause this proposal to be disregarded. I ask only that someone with the relevant expertise read pages 4 through 9 before making that decision. He folded the pages, handed them to the same guard the next morning, and asked him to mail them. The guard looked at the address on the envelope for a moment, and then put it in his shirt pocket without a word. 2 weeks later, a car arrived at the camp. Not a military vehicle, a dark, civilian sedan, Arizona plates, driven by a man in khaki without rank insignia. In the passenger seat was a colonel named Whitmore, late 50s, reading glasses, a manila folder on his knee that Victor recognized even from across the yard. The colonel spoke to the camp commander for approximately 4 minutes. Then he walked to the processing tent, sat down across a folding table from Victor, opened the folder, and read in silence for a long time. When he was finished, he looked up. Page 6, he said, the stress calculation on the hub bearing. Walk me through it. Victor walked him through it. The colonel listened. He asked 3 follow-up questions. They were good questions, the kind that only came from someone who had spent real time thinking about rotary systems. Victor answered each one. Then the colonel closed the folder. You have 90 days to demonstrate the auto-rotation principle at reduced scale, he said. If it works, you'll get 14 months and a facility to build a full prototype. You'll be working under Army contract. You will not leave the base without escort until we determine your clearance status. He paused. Do you have any questions? Victor thought about it. Will I have access to a lathe? The colonel almost smiled. We'll get you a lathe. Marana Army Airfield, in the summer of 1943, had the organized chaos of a place doing 10 things at once. Trainers taking off and landing every 40 minutes, ground crews moving between dispersal bays, supply convoys kicking up red dust on the service roads. Victor arrived with a single military escort, a reassigned workspace in a maintenance hangar at the eastern end of the field, and a contract that described his project as Special Rotating Wing Glider Development, Specification M 1942. The first person he met was Sergeant Dale Breck. Breck ran the supply and equipment allocation section for the Eastern hangars. He was 41 years old, built like a man who had spent 20 years doing physical work and saw no reason to stop, with the kind of unhurried competence that comes from being genuinely good at a job most people don't notice until it goes wrong. He had a degree in mechanical engineering from the University of Illinois that he almost never mentioned. He had read Victor's preliminary technical summary before Victor arrived because the colonel had forwarded it with a requisition request, and Breck handled all requisitions. He handed Victor a coffee, looked at the engineering notebooks under his arm, and said, "What do you need first?" Not, "What is this?" Not, "Does it actually work?" Just, "What do you need first?" Victor, who had spent the past year explaining himself to people who responded with skepticism or silence, stood for a moment before answering. A rotor hub, 4-point mounting, and somewhere quiet for calculations. Breck nodded. "Hub I can find by Thursday. Quiet space is a problem. Come back around 6 this evening." Captain Roy Callahan arrived at the project 3 weeks later. He had the look of a man who had been flying since before it was fashionable. Not tall, not particularly imposing, with a face that had spent too many years at altitude, and a way of moving through a space that suggested he was always calculating exit routes. He was 31. He had flown trainers, bombers, and 3 different experimental aircraft, one of which had required him to land a machine with no working tail surfaces in a field outside Tucson. He had walked away from it. He had been assigned to Victor's project because he was the only test pilot on the base who had not already asked to be excluded. His first meeting with Victor lasted 8 minutes. Victor walked him through the basic principle, the unpowered rotor, the auto-rotation mechanism, the way forward movement through air would cause the blades to spin, the spin to generate lift, the lift to support the weight of a standard military jeep and its crew during a controlled descent. Callahan looked at the diagrams. He looked at the scale model on the workbench. He picked it up, walked to the open hangar door, dropped it from shoulder height, and watched it spin slowly down to the concrete floor. He set it back on the bench. "And someone has to ride in the jeep while this is happening." 2 people, Victor said. A pilot controlling the rotor, a driver ready to operate the vehicle on landing. "Can I ask what the previous test pilot's opinion was?" "There was no previous test pilot," Victor said. "You're the first." Callahan looked at Breck, who was leaning against the wall with the expression of a man who had already made his peace with whatever was about to happen. "Any chance of a decent meal on this base?" Callahan asked. "Chili on Thursdays," Breck said. "I'll think about it until Thursday." He came back the next morning. The project briefing for the Senior Review Board was held in late October 1943. 7 officers, 3 engineers, 4 administrators who had been included because the Army ran on process and process required witnesses. Victor stood at the front of a room that smelled of cigarette smoke and floor wax and presented his case methodically. The weight of a standard Willys MB, the rotor diameter required, the minimum tow speed for auto-rotation, the comparison to conventional gliders, cost per unit, required infrastructure, trained pilots stranded on the ground as infantry once the glider landed, 1 Waco glider, 1 jeep, 1 flight, the glider abandoned, 7 rotor-equipped jeeps for the cost of that 1 glider. A general in the 3rd row leaned back in his chair. "You were in an internment camp 14 months ago," he said. "Not an accusation, a statement delivered in the tone of a man presenting an obstacle." "Yes," Victor said, "and now you're asking this board to approve the development of a military aircraft." "I'm asking this board," Victor said, "to look at page 4. He picked up the scale model from the table beside the podium. He held it at shoulder height and released it. The model fell slowly. The rotor spun, it rotated twice, 3 times, descended in a smooth spiral, and came to rest on the floor in front of the general's table without tipping over. The room was quiet. Victor did not say anything else. He had learned, across 40 years and 2 countries and a century, that periodically went insane. That the moment after a thing proves itself is the moment to let the silence do the work. The general looked at the model for a long moment. Then he looked at the colonel beside him. The colonel opened a folder and produced a single authorization page. 3 signatures. 14 months of funding. They did not approve it because they believed in Victor Arndt. They approved it because they had run out of better options, and a man who could prove his math on the floor of a review room with a scale model built from scrounge materials was at minimum a man worth watching. Victor picked up the model, tucked it under his arm, and walked back to the hangar. He had work to do. The first test happened on a Tuesday morning in November 1943. The air was cold enough to see breath. The sky over Marana was the particular shade of blue that only exists in the Arizona desert in winter. Deep, cloudless, the kind of sky that makes everything below it look small and temporary. Victor stood at the edge of the runway with a clipboard and a stopwatch, watching a 4-ton Diamond T military truck idle at the far end of the tarmac. Behind the truck, connected by a 40-foot tow cable, sat the rotor buggy. It looked like something assembled from a fever dream. A standard Willys MB Jeep, olive drab, canvas top removed, windshield folded flat. Bolted to the roof was a steel pylon rising 6 feet above the chassis. From the top of the pylon extended the rotor hub, and from the hub 2 blades swept outward, each one roughly 20 feet long, angled slightly upward at their tips. At the rear of the Jeep, a streamlined tail fairing extended backward with twin vertical fins. The whole assembly looked like someone had taken a perfectly reasonable military vehicle and explained it incorrectly to a very confident engineer. Callahan sat in the passenger seat with both hands on the control column that descended from the hub above him. He was wearing a leather flight helmet and an expression of careful neutrality. Breck had not been asked to ride along. He had simply climbed into the driver's seat before anyone thought to make it a question. Victor raised his hand. The Diamond T driver pressed the accelerator. The truck moved. The cable went taut. The Jeep rolled forward. At 30 miles an hour, the rotor blades began to turn, slowly at first, catching the air, finding their angle. Victor watched the RPM gauge mounted to the pylon. The needle climbed, 40 miles an hour. The blades were spinning now, a low rhythmic whomp that Victor could feel in his chest more than hear. 50 miles an hour. The rotor was at speed. The Jeep did not leave the ground. The wheels stayed on the tarmac. The rotor spun. The chassis rattled. At the end of the runway, the Diamond T ran out of road and slowed to a stop. Victor wrote 3 numbers in his notebook, circled all 3, and stood very still for a moment. The truck had topped out at 53 miles an hour. Auto-rotation needed 65 minimum to generate enough lift for a loaded Jeep. The gap was not enormous, but in engineering, a gap that is not enormous is still a gap. He walked back to the hangar without saying anything. Callahan climbed out of the Jeep, pulled off his helmet, and looked at Breck. "That was the test?" "That was the first test," Breck said. "They ran it again Wednesday. The same result. Thursday, Victor adjusted the blade pitch angle by 3 degrees and they ran it again. The rotor spun faster. The Jeep still didn't leave the ground. At the peak of the run, one wheel lifted fractionally, perhaps 2 inches, and then came back down as the truck decelerated 2 inches. Victor stared at those 2 inches in his notebook for a long evening. The problem was simple and intractable. The Diamond T could not go fast enough on a paved runway of finite length to give the rotor what it needed. He could optimize the blade angle further, but there were limits to what geometry could accomplish when the fundamental issue was speed. He needed something faster, considerably faster. And on a working military installation in the middle of the Arizona desert, in November 1943, considerably faster was not an obvious resource. He was sitting in the hangar at 7 in the evening, notebooks spread across the workbench, when Breck appeared in the doorway. Breck had a way of entering a space that suggested he had already decided whether to speak before he opened his mouth. He stood for a moment, looking at the notebooks and then at Victor, and then he pulled a folded piece of paper from his breast pocket and set it on the bench. It was an asset inventory form. One line was highlighted in pencil. Victor read it. Then he read it again. "Where?" he said. "Bay 7, Breck said. "North storage. It's been there since August of last year." Bay 7 was a locked corrugated steel structure at the far northern end of the base, used primarily for equipment awaiting disposal or reassignment. Breck had the key. He unlocked the padlock, rolled the door back on its track, and reached inside to pull the cord on a hanging work light. The Packard Twin 6 sat in the center of the bay under a canvas tarp. Breck pulled the tarp back. It was a 1933 Packard, supercharged, built for private racing by an owner in California who had modified the engine to somewhere north of 400 horsepower and then used the car to move undeclared goods between Los Angeles and Phoenix until federal agents impounded it in the summer of 1942. The car had moved through 3 processing facilities before arriving at Marana, where a supply clerk with no automotive background had attempted to enter it into the base inventory system and, finding no applicable category for a supercharged civilian racing vehicle, had classified it under the nearest available heading. "Aircraft auxiliary towing equipment," Victor read from the form. "Assigned serial number and everything," Breck said. "It's in the system as base support hardware. Someone in logistics signed off on it without ever seeing it in person." Victor walked around the car slowly. He crouched at the rear and examined the frame. He stood and looked at the wheelbase, the tire condition, the engine cowl. "Has it been started recently?" "I ran it last week," Breck said. "Took about 4 minutes to turn over. Once it caught, it was fine." "How fast?" Breck considered this. "I took it up to about 90 on the service road before I decided that was probably enough. 90 miles an hour. On a base road, in the dark, almost certainly." Victor looked at him. "You drove a supercharged Packard at 90 miles an hour on the service road at night." "I wanted to know if it worked," Breck said, with the tone of a man who found the question slightly beside the point. Victor almost smiled. It was the closest he had come in some time. The first Packard tow test ran on November 27, 1943. The car had been moved to the main runway in the early morning before other operations began. Breck drove. The tow cable ran from the Packard's rear frame, fitted with a military-grade tow hook that Breck had machined himself over 2 evenings, back to the front axle of the Jeep. Callahan was in his seat, control column in hand. He had stopped making jokes about last meals approximately 2 weeks earlier, which Victor took as a sign that the project had become real to him. Victor stood at the runway edge with his stopwatch and watched. The Packard accelerated. Breck was smooth, not violent, but committed. The car found its speed quickly, the supercharged engine settling into a sound that belonged on a circuit track in another decade and another world. The tow cable went taut. The Jeep rolled. The rotor began to turn. At 50 miles an hour, Victor started the stopwatch. At 60, the rotor was singing, a rhythmic, cycling pressure in the air that he had calculated but never actually heard at this scale before. At 65 miles an hour, the front wheels of the Jeep left the ground. Not 2 inches, the wheels rose cleanly and stayed up. 3 feet of air between rubber and tarmac. The rotor disc tilted slightly as Callahan made an input on the control column, and the Jeep flew. From his position at the runway edge, Victor watched it happen and felt the private, unrepeatable sensation of a calculation that has stopped being theory and become the world. Not hope, not relief, certainty. The specific condition of a thing behaving exactly as the mathematics said it would, out in the open air where anyone could see it. He wrote the numbers down. He did not stop writing for 40 minutes. Callahan came back across the tarmac after Breck turned the car around. He climbed out of the Jeep and stood with his hands on his hips, looking up at the rotor blades still ticking over slowly in the residual airflow. "It flew," he said. "Yes," Victor said. "A Jeep flew. A Jeep flew." Callahan nodded slowly, the way a man nods when information is correct but his mind needs a moment to file it properly. "Same time tomorrow," he said. "Earlier," Victor said. "I want more runway." Through December and into January, they ran the Packard tests every day the weather allowed. Victor adjusted blade pitch in increments of half a degree. He changed the damping on the rotor hub. He modified the tail fairing geometry twice. Each change produced data. The data produced the next change. The Jeep flew higher, longer, more consistently, and then, at somewhere above 70 miles an hour, the vibration began. It started as a tremor, something Callahan described as feeling like a rough road surface transmitted through the seat and the control column simultaneously. Victor measured it on a gauge mounted to the pylon. At 72 miles an hour, the amplitude was manageable. At 78, it was uncomfortable. At 82, during a test in late January, the control column jerked hard enough to pull free of Callahan's grip entirely and spin in a full rotation before he could recover it. Callahan brought his hands back to neutral and held on. The Jeep descended to the runway. The Packard slowed. When everything stopped, Callahan sat without moving for a moment, then opened and closed his right hand several times, examining his fingers. "The column hit my palm on the way around," he said, when Victor reached the Jeep. "I'm fine, don't make the face." Victor was not making a face. He was looking at the rotor hub. That evening, he stayed in the hangar until 3 in the morning. The vibration was a resonance problem. The rotor blades were generating an oscillating force at high speed that fed back through the hub into the control column. The solution existed. It required rethinking the blade attachment geometry and adding rubber damping at 3 specific points in the hub assembly. He worked through it on paper. Then he started on the metal. Breck appeared at 11 p.m. with 2 cups of coffee and read the technical notes Victor had set aside. He asked 2 questions, then began fabricating the modified damping mounts on the lathe without being asked. They worked in parallel until 2:30. Neither of them mentioned what would happen if it didn't work. It is worth pausing here for a moment, because while Victor was working through a resonance equation in a maintenance hangar in Arizona, something was happening on the other side of the world that illuminates exactly what was at stake in getting this right. In September 1942, the Soviet Air Force had attempted their own version of the same idea. The Antonov A-40 was an exercise in ambition without restraint. Engineers had taken a T-60 light tank, fully functional and fully armed, and bolted a biplane glider wing assembly directly to the hull. The idea was precise and not unreasonable in theory. Tow the tank to altitude, release, glide to the battlefield, shed the wings, drive straight into combat. The single test flight lasted less than 10 minutes. The tow aircraft, a TB-3 heavy bomber already aged past its useful life, immediately overheated from the drag of a flying tank. The pilot, Sergei Anohin, released early. He glided the tank into a field outside Moscow, managed a landing that did not kill him, detached what wing components he could, and drove back toward the airfield. The perimeter guards, seeing a tank approach with partial wings still attached to its hull, assumed it was a captured German prototype and detained him at gunpoint until he could produce identification. The project was cancelled immediately. No Soviet aircraft in production could handle the tow load. Victor knew this story. He kept a copy of the preliminary Soviet report in a folder at the bottom of his desk and read it occasionally. Not as a cautionary tale about overreach, but as a precise map of the mistakes he was not allowed to make. The Soviets had built something spectacular that the system couldn't support. Victor was building something the system could use tomorrow morning. The difference between those two approaches was not philosophy, it was engineering discipline under pressure. He understood pressure. He had been learning it for a long time. By June 1944, a B-25 Mitchell medium bomber had replaced the Packard as the primary tow vehicle. The Packard had done what it needed to do. It had proved the principle, generated the data, and gotten the project to the point where the Army was willing to commit an actual aircraft. The car was moved back to Bay 7 and covered with its tarp. Nobody signed a form for it. Nobody updated the inventory. The B-25 provided the power and altitude the next phase required. Ground runs first. The bomber rolling down the runway at increasing speeds, while the Jeep followed on the cable, wheels just off the tarmac, rotor spinning. Victor watched the data, adjusted, watched again. September 11th, 1944. The date had been set for 3 weeks. Weather window, aircraft availability, crew scheduling, safety observers from the review board, it had taken time to align. Victor had used the time. He had run every calculation he could run. He had tested every component he could test on the ground. He had done the thing that engineers do in the days before a test they cannot fully control. He had prepared until preparation became a form of patience, and then he had waited. That morning was clear. 70 degrees at 6 a.m. No wind. Callahan arrived at the hangar at 5:30. He drank coffee, inspected the Jeep's rotor assembly himself. He had learned enough over 10 months to know what he was looking at, and said nothing that wasn't operational. Breck performed the pre-flight checks with the methodical completeness that Victor had come to rely on as a constant. When he finished, he climbed into the driver's seat of the Jeep without ceremony and adjusted the mirror. He did not look at Victor for permission. He did not announce what he was doing. He simply settled into the seat the way a man settles into the seat of something he has already decided to see through to the end. Victor watched him for a moment, then he looked down at his clipboard. At 8:15, the B-25 taxied to the start of the runway. The tow cable ran back from the bomber's tail to the front axle of the Jeep. Callahan was in position, both hands on the control column, eyes forward. Victor pressed the stopwatch button. The B-25 throttled up. The cable went taut. The Jeep moved. The rotor turned. The wheels lifted. Not 2 inches, not 3 feet. This time, the Jeep climbed, and it kept climbing, and at 120 meters above the Arizona desert, the machine was in free flight, and the mathematics were correct, and for 45 seconds, everything was exactly as it should have been. And then the vibration came back, harder than it had ever come before. Callahan held the control column with both hands and did not let go. That was the whole of it, reduced to its simplest form. 8 minutes above the Arizona desert. The B-25 ahead of them slowing towards stall speed to keep the combination manageable. The Jeep pitching and yawing behind its cable, like something trying to become free of the arrangement entirely. Breck in the driver's seat, hands on the wheel, eyes forward, completely silent in the way of a man who has decided that silence is the only useful thing left to offer. Below, Victor wrote numbers. He stood at the edge of the runway with his clipboard pressed flat against his chest to keep the pages from turning in the prop wash, and he watched the machine he had designed on toilet paper in an internment camp hang in the air above him, and he wrote down everything it told him: altitude, oscillation frequency, the angle of the rotor disc at each phase of the pitching cycle, the behavior of the tail fins under load. He did not look away, not once. This was the discipline that separated Victor Arndt from other engineers. Not intelligence, not creativity, not the capacity to solve problems that other men couldn't see. Those things he had in abundance, but so did others. What separated him was the ability to watch something go wrong and keep recording, to hold the scientific instrument steady while the human being behind it wanted to run. He kept writing. The B-25 descended first. Long, shallow approach. The bomber's wheels touched the runway, and the aircraft decelerated, and the Jeep, still on the cable, still in the air, made 3 violent pitching movements before its wheels found the tarmac. Breck hit the accelerator immediately, chasing the slowing bomber to keep the cable slack, and drove flat out down the runway until the B-25 stopped, and everything was finally, completely still. Victor reached the Jeep in 4 minutes. Callahan was in the seat. He was not moving. His hands were in his lap, and he was looking at the rotor blades above him as they turned their last slow rotations and stopped. His right hand was opening and closing against his thigh. The same thing Victor had watched him do after the January ground test, after the cable had snapped free and the column had nearly broken 2 of his fingers. Victor stood at the side of the Jeep and waited. He had learned over 10 months of working with Callahan that the man processed physical experience from the inside out. He needed a minute. Interrupting that minute was not useful. After a while, Callahan turned and looked at him. "The column went free twice," he said. "I got it back both times. I know, I saw. At about 4 minutes, there was a moment where I wasn't certain I could hold the angle." Victor nodded. He had seen that too. The fractional change in the rotor disc tilt, the Jeep's nose dropping 2 degrees before recovering. "Did you get what you needed?" Callahan asked. Victor looked down at the clipboard. 14 pages, every number the flight had produced, recorded in the small, precise handwriting he had been using since his first engineering notebook at the University of Vienna in 1923. "Yes," he said, "I got what I needed." Breck climbed out of the driver's seat and walked to the front of the Jeep and put both hands on the hood and stood there, looking at the ground for a long moment. Then he straightened up, looked at Victor, and said, "Same time next week?" The 3 of them stood in the thin morning shadow of the B-25's wing and understood that the question meant something larger than the words. It meant, "We are still here." It meant, the machine flew. It meant, whatever happens next, this was real and we were present for it, and that is not nothing. Victor looked at the 14 pages on his clipboard. "Give me 6 weeks," he said. "I know how to fix the resonance." The official report filed by the Airborne Forces Experimental Unit at Marana described the September 11, 1944 test in the following terms: trial completed, vehicle achieved sustained altitude of approximately 400 feet, duration of free flight estimated at 8 minutes, handling characteristics at speed, present technical challenges requiring further development, assessment, highly satisfactory, highly satisfactory. Victor read those 2 words sitting at his workbench that evening, the report in one hand and a cold cup of coffee in the other. There was something in the bureaucratic language of Army documentation, its extraordinary capacity to compress the truth into the mildest possible framing, that he had stopped finding absurd somewhere around the 4th or 5th report. Now he found it clarifying. Highly satisfactory meant they were still interested. Still interested meant the work continued. He opened the notebook to page 15 and began designing the modifications. The resonance problem had a solution. He had been approaching it since January, but the flight had given him data that ground tests couldn't provide, specific frequency signatures at specific airspeeds that now allowed him to identify exactly where the oscillation was entering the system. The blade attachment geometry needed revision. The pitch linkage in the hub assembly needed a change of approximately 11 millimeters in the moment arm. He estimated 6 weeks of fabrication and 3 weeks of ground testing before they could go back to flight. He told Breck on Monday morning. Breck said, "I'll have the materials by Wednesday." Then he poured himself a coffee, sat down across the bench from Victor, and looked at the modified hub drawings for a long time without speaking. "It's going to work," Breck said finally, "not as encouragement, as assessment." "Yes," Victor said, 6 weeks is enough time to get it right. If we start Wednesday, we'll start Wednesday. This was the register in which Victor and Breck conducted most of their important conversations, statements that sounded like facts but functioned as commitments, precision substituting for sentiment in the way it does between men who trust each other's competence entirely and have never found it necessary to discuss the trust itself. The letter arrived on a Thursday in November. It came through the Colonel's office, forwarded from Washington, on Army stationery with an unfamiliar header. Victor read it standing in the hangar doorway with his coffee cooling in his other hand and the morning light coming in flat and pale over his shoulder. 3 paragraphs. The first cited the successful conclusion of Operation Overlord in June and the operations that followed, noting that the Waco CG-4A glider program had delivered 281 jeeps to the European theater during the Normandy landings, and that the system had proved effective at the required operational scale. The second noted that Operation Market Garden and Operation Varsity had further validated the mass-produced glider as the primary vehicle delivery platform for airborne operations. Current production rates were sufficient to meet anticipated requirements for the remainder of the conflict. The third informed Victor Arndt that Special Rotating Wing Glider Development Program, Specification M1942, was hereby concluded effective immediately. All materials and equipment were to be inventoried and secured. His contract would be formally closed within 30 days. Victor read it twice. Then he folded it and put it in his shirt pocket and stood in the doorway for a while, looking at the jeep. The light moved across the rotor blades as the morning progressed. The tail fins threw thin shadows across the hangar floor that shifted slowly as the sun climbed. The machine sat in the particular silence of a thing that had been extraordinary and was now finished, and Victor stood there long enough to let the difference between those two conditions become clear. The project had not failed. He needed to understand that completely and without consolation before he could think about anything else. The project had not failed. The engineering was sound. The principle was proven. The machine had flown. It had flown badly, with handling problems that were solvable and a vibration issue he now knew precisely how to fix. And it had been cancelled anyway, not because it didn't work, because the war had moved faster than the program could move, and the army had found another way, and the other way was good enough. Good enough. Victor had spent his entire professional life in pursuit of something better than good enough, and now good enough had ended his project. There was a particular kind of justice in that if you looked at it from the right angle. He was still deciding what angle that was. He walked to the jeep, put his hand flat on the hood, and held it there for a moment. The metal was cold. He could feel the texture of the paint under his palm. The slightly rough surface of military olive drab, applied in a factory in Toledo by a man who had no idea what the vehicle was going to become. Then he went inside and started the inventory. Callahan came to find him that evening. He sat on the workbench while Victor catalogued components and did not offer false comfort, which Victor had come to understand was one of Callahan's most important qualities. He sat and watched the work, and after a while he said, "For what it's worth, I think it was the right machine at the wrong time. That's true of a lot of things," Victor said. "Doesn't make it easier, no." They were quiet for a while. The inventory continued. Breck appeared at some point with coffee, and then disappeared again without saying anything, which was also one of Breck's important qualities. "What happens to you now?" Callahan asked. Victor set a component carefully into its crate. "I have some conversations to have. Some people who have been watching the project." "Bell?" Victor looked at him. "The Colonel mentioned it," Callahan said. "I'm not supposed to know." "Then you don't know." "Right." Callahan drank his coffee. "For what it's worth, and I recognize I'm not an engineer, I think the data you have in those notebooks is worth more than the project itself. You know things about rotor behavior at speed that nobody else knows, because nobody else has done what you did." Victor considered this. "The notebooks go with me," he said. "That was in the contract." "Good," Callahan said. They sat together in the hangar for another hour, not talking much. The way men sit together when there is nothing useful to say, and leaving would feel like the wrong answer, and the right answer is simply to remain. In the spring of 1945, Victor Arndt accepted a position with Bell Aircraft Corporation in Buffalo, New York. He arrived in April with 3 engineering notebooks, 14 months of flight test data from a program that officially no longer existed, and the modified hub drawings he had completed the week the cancellation letter arrived, the designs he had never gotten to build. The Bell engineering team was serious. These were not men pursuing a curiosity or satisfying a bureaucratic requirement. They were building towards something real, a rotary wing aircraft that could be certified, manufactured, and sold. They needed people who understood what happened to a rotor at the edge of its operational envelope. They needed someone who had been there. Victor spent his first 3 days at Bell doing nothing but transferring what he knew, not from memory, from the notebooks. Every data point from every Packard tow test and every B-25 run, organized into the language the Bell team used, mapped onto the design problems they were currently trying to solve. On the 3rd day, the chief engineer looked up from the Arizona data and said, "Where did you get this?" "A Jeep," Victor said. The chief engineer looked at him. "A modified Willys MB," Victor said. "In the desert. It's a long story." Years later, a journalist writing about the early history of American helicopter development tracked down Victor Arndt at his desk at Bell and asked him what he remembered most about the Arizona tests. Victor was quiet for a moment, in the way of a man who has many accurate answers and is deciding which one is true. "The toilet paper," he said. The journalist waited. "I designed the rotor hub on toilet paper in an internment camp outside Marana, the same camp that was 12 miles from the airfield where we eventually flew the machine." He paused. "When the Model 47 received its certification, I still had those pages. I kept them in the front cover of the first Arizona notebook, the one with the Packard tow data." Another pause. The math was identical, not similar. Identical. Nothing changed between the camp and the certificate except time and materials, and the willingness of other people to believe it was possible. He went back to his work. The journalist stood in the doorway for a moment, not sure if the interview was over, and then left without asking another question. It was, Victor would have said if asked, the correct response. Some things describe themselves completely, and the best thing a listener can do is understand that and stop talking. The Federal Aviation Administration issued the Bell Model 47's Civil Airworthiness Certificate in March 1946. It was the first certificate of its kind issued to a helicopter in American history. Victor was not in the room for the ceremony. He was in the hangar, running a pitch geometry check on the next prototype, when Breck, who had followed him to Bell 6 months after the Marana project closed because Breck went where the work was, came in with a newspaper folded to the relevant page and set it on the bench without a word. Victor read the article. It was 3 paragraphs. It mentioned the certificate and the aircraft specifications and a quote from a Bell executive about the future of rotary wing aviation. It did not mention the rotor buggy. It did not mention Marana. It did not mention a supercharged Packard towing a military jeep across a desert runway, or a man working through resonance equations alone at 3 in the morning, or a flight test that the official record described as highly satisfactory and that had nearly broken 2 of his pilot's fingers. It didn't need to. Those things had already done their work. They were in the data, they were in the design, they were in every calculation that had gone into the machine that had just received its certificate, visible to anyone who knew where to look and what they were looking for. Victor set the newspaper down and went back to the pitch geometry check. Breck made 2 cups of coffee and set one on the bench beside the notebook. "Same time next week?" Breck said. Victor picked up the coffee. Earlier, he said. I want to check the tail rotor data before the morning run. Captain Roy Callahan received the Air Force Cross in January 1945 for courage demonstrated in experimental aircraft testing. The citation was 2 sentences. It did not describe what the testing involved. He went home to Ohio after the war and taught physics at a state university for 22 years. He was, by all accounts, a good teacher, the kind who assigned problems that didn't have clean solutions and waited without impatience while students discovered that the work itself was the point. In 1971, he privately published a short memoir of his wartime flying career. It covered 12 aircraft and 4 years of test work. The chapter on the Marana project was the longest in the book. He ended it with a single paragraph. I have been asked many times whether I was afraid during the Arizona tests. I was. Anyone who says otherwise about that kind of flying is either lying or wasn't paying attention. But underneath the fear was something that I have spent 30 years trying to describe accurately and have not quite managed. The closest I can come is this. It was the feeling of being in the presence of a thing that is correct. Not successful. Correct. Victor Arndt had worked out the mathematics in an internment camp on toilet paper, and when I was sitting 400 feet above the desert with a control column doing its best to destroy my hands, the machine was behaving exactly as the mathematics said it would. Badly, violently, with problems that needed solving, but within the predicted parameters, within the understood physics, within the world that Victor had mapped before any of us had seen the hardware. I have spent the rest of my life looking for that feeling in smaller places. I have found it occasionally. It is never small. The rotor buggy prototype had its rotor assembly and tail fairing removed in December 1944. The Jeep chassis was transferred to general ground transport duty at the base. After that, the records trail goes cold. The Packard Twin 6 remains listed in the Marana Asset Inventory as Aircraft Auxiliary Towing Equipment, Hardware Number 7M 1942T. The disposition column reads, Transferred to Civilian Asset Pool, February 1946. There is no receiving signature, there is no forwarding address. A machine that had been formally classified as an aircraft by the United States Army that had towed a flying Jeep across a desert runway in the winter of 1943 that had been driven at 90 miles an hour on a base service road in the dark by a sergeant from Illinois who wanted to know if it worked, simply disappeared into the American post-war landscape and was not seen again. Somewhere it may still exist. In a barn in the Southwest, or a private collection in California, or a garage where someone has been meaning to sort through the old man's things for years and hasn't gotten around to it yet. A 1933 Packard Twin 6 supercharged rear frame fitted with a heavy-duty tow hook that has no obvious explanation, paperwork, if any survives, carrying a military asset number that leads back through the right archives to a maintenance hangar in Arizona and a man who needed to go faster than any truck on the base could take him. Victor Arndt never looked for it. He had what he came for. The 14 notebooks, the data. The certainty, earned across toilet paper calculations and scale models and Packard tow runs and one genuinely terrifying morning at 400 feet, that the geometry of spinning blades could do what he had always believed it could do. He had the Bell Model 47's airworthiness certificate on the wall of his office. He had the modified hub drawings he had completed the week the cancellation letter arrived and never gotten to build, filed in the back of the last Marana notebook, waiting for a project that needed them, and finding one eventually, as correct solutions always do. He had the postcard from Breck that said, "Same time next week," kept in the front cover of the first notebook, next to the toilet paper pages. The Jeep was somewhere in the Arizona desert, working as a ground vehicle, carrying supplies between hangars, doing the job it had been built for. The Packard was somewhere in America, waiting, and the Bell Model 47 was in the air. That was enough. That was, Victor would have said, considerably more than enough. He had proven the math. The rest was just time.